Good day. This is item analysis for the first attempt of CSC 243, Module 3 assessment. From our initial breakout of details, our students completed the first attempt and the average score was a 76%, which is a very strong first showing. Anything that's high level C or north of that is a good result. And the average student took 49 minutes out of the full 60 minutes available. We'd expect this. The statistics in Blackboard don't account for mastery learning, so there are cases where all students knew the answer, and so Blackboard could not distinguish between the range of student answers and considered some of the questions to be poor questions or could not even calculate. But we expect that. The breakout between difficulty levels was decent. So we had 7 easy questions, 17 medium, and 1 hard. So what we want is a case where we don't have too many easy questions or too many hard questions. And the fact that 17 were designated as medium questions, that's acceptable. The fact that 7 were considered easy is not out of bounds. So we're going to review the items that pose the greatest challenge for students in this final module, beginning at the bottom. And when we reach this point, we'll zoom on up to capture items where multiple answer full credit wasn't awarded, or ordering or matching wasn't awarded. This would be one multiple answer involving DNS that had a poor outcome we truly want to take a look at. Anything where you couldn't calculate, all students got this question correct. Communicate outside the LAN, must include a gateway. Yes, everyone got that correct. And nearly everyone got this one correct. So we won't be reviewing these two, but you're free to let me know if you'd like me to review anything after the item analysis is finished. Our first challenge item for the assessment involved larger IP class assignment. So a company informs the internet service provider that it needs twice as many public IP addresses than the existing Class C. A Class C address has 256 addresses. 3 of those are taken up. 253 are usable. 1 is used to designate the network ID, the gateway, and the broadcast each. The ISP informs the company they can upgrade to a Class B address range at an additional cost. Well, a Class B address range has 65,536 addresses. 65,533 are usable. 1 for the network ID, 1 for the gateway, and 1 for the broadcast. The question reads, what is the greatest disadvantage of using this method to resolve this need? Choose the best to answer statement from those listed. Well, they need twice as many and they had 250. That means they need 500. If the ISP gives them a Class B address range, they're using an outdated method to provision public IP addresses. That's terribly inefficient. It would waste too many it would waste too many public addresses. So if it only needed 500, but it's giving them 65,533 usable addresses, oh my gosh, there are 65,000 unused public addresses. This is terrible. But that's the answer that's correct. A number of students answered the next 2 items. A Class D address range is specified to provide twice as many. Class D is actually smaller and it's experimental. It's not really used. That's not a good answer choice. A Class C can still be used. The ISP simply needs to slide the subnet mask 1 place to the left. That would be the ideal thing for the internet service provider to do. But that's not what the question asks. The question asks, what is the greatest disadvantage of using this method to resolve this need? So this answer choice provides instead, it's a trick question, but this answer choice provides instead. If the question read, what is a better method to resolve this need, that would be your answer choice. But that's not what the question asks. It says, what's the greatest disadvantage of using this method to resolve this need? It wastes too many addresses. In your dealings with service providers, you're going to need to provide why there's a disadvantage and provide the optimum solution. It's kind of a 1-2 punch. But the first step is to say, no, we're wasting. So part of your charge as technology and computer science professionals is to help inform the public. And part of that challenge is to contrast. Oh, look at the horrible waste. Oh, here's a much better way to do it. So if the question read, what is a better way to do this, that would be the answer. I hope that explains everything. Okay, the next item that posed a challenge, different sessions, same server. TCP and UDP sessions are formed in such a manner that they can be distinguished from one another. The server uses the same IP address and the same well-known port for connections. How can a server and so many clients distinguish between the different sessions active at any one time to keep the data separate? Choose the best answer statement from those listed below. The correct answer is each client has a different ephemeral port, a higher numbered port, used to represent the unique session. So when you're identifying the session, you have a server socket, a client socket, separated by a comma, and with each different client, they have different numbers. Even if you're using multiple clients from the same IP address, in a case where NAT or PAT is occurring, port address translation is occurring, you have different sessions. Students chose the other answers. The server uses a different well-known port to represent the unique. No, the server doesn't use a different well-known port. The server can't use a different well-known port if it's HTTP. The well-known port is 80 for each web connection, or 443 for each encrypted web connection, HTTPS. It can't use a different one. A three-way handshake establishes a different session ID for TCP and UVP connection. That's just a bogus answer. The three-way handshake is only used for TCP and not for UDP, and that's actually a typo. So that's not a correct answer. The server uses the same ephemeral port number for each client connected. No, the server doesn't use an ephemeral port number. The server uses a well-known port number, a lower numbered port, from 0 to 1056, in some cases through 1435, or in the case of SQL. But the server never uses an ephemeral port. That's only used by the client. So this is the correct answer. DNS error. You are hired to troubleshoot a network failure on a DNS server that can properly complete data exchanges with other DNS servers. So that's your clue. In the context of this, we're talking about the DNS server that's working with other DNS servers, but cannot function with network clients that need to look up the IP addresses listed in the DNS records. Note that recent changes were made to security settings on the DNS server to reduce exposure to hackers. What action would be likely to resolve the errors? So if there were security changes on the network, it's likely that some firewall changes were made, right? And you see that common element in each of the answer choices. But it says the firewall on the DNS server needs to include a rule to allow UDP port 53 inbound connections. So when a DNS server is exchanging data with other DNS server, it uses TCP port 53, a three-way handshake, to guarantee delivery, correct delivery, of DNS records that are exchanged between servers. But when it's being used by clients to resolve domain addresses, to IP network addresses, that occurs on UDP 53. So the rest of these answers are all incorrect. Firewall on DNS server needs to be enabled except for IPv6. That has nothing to do with it. We're not even talking about IPv4 versus IPv6 here. And working something with IPv6 wouldn't resolve the IPv4 problem. Firewall on the DNS server needs to include a rule to allow for inbound connections. Well, actually, a DNS server is querying other DNS servers, and other people control those servers. So having an inbound connection for DNS this way would be good, but that's not going to resolve the client errors. So that is an element that you want to configure, and that is a decent answer, but the issue is that you're having a failure with the clients. It says the DNS server can properly complete data exchanges. So the error doesn't have to do with the DNS to DNS server side. So that's the catch here, is that we can communicate properly with DNS servers. The firewall on DNS servers needs to be enabled except for IPv4 private connections. That's a bogus answer. That has nothing to do with the corporate firewall. There are private, public, and private domain and public profiles on client firewalls, but we're talking about a corporate firewall here. So IPv6 Essentials Part 2. In contrast to IPv4, IPv6 offers significant improvements for IP networks. However, a leading concern related to implementation has been noted. Which statement best reflects this issue? Network security can be an issue when existing IPv4 networks are mixed with IPv6 networks. That is the correct answer. The other two answers that students chose incorrectly most often, IPv6 networks that use a double colon are susceptible for a number of well-known exploits. That's a typo, but that's a bogus answer. A lot of IPv6 networks use a double colon to collapse all the contiguous zeros. That's a normal convention. There's nothing wrong about that. IPv6 networks do not use DHCP and lack the means to automate client address assignments. That's an incorrect statement. The automatic client assignment is built into the protocol. They just don't use DHCP to do it. So the statement is incorrect because it says and lacks the means to automate. Now there's a method, it's just not DHCP. So that statement is false. This one, most recent operating systems do not yet offer functional IPv6 protocols natively. That's incorrect. Every current operating system, Linux, Mac, Windows, all offer and enable IPv6 out of the box. That's actually a problem. So that's an incorrect statement. They all offer it, and what's worse, they all enable it even if it isn't functional. So you have those issues. IPv6 Essentials Part 1. Choose the correct statement from those listed below. Among the notable network improvements that IPv6 offers, the following is considered the primary reason to adopt this new standard. It provides ample public network addresses at a time when IPv6 addresses have run out. That's the single biggest reason why IPv6 was implemented. We also needed better security. That's true. But that's not the reason, the primary reason. IPv6 network allows shortcuts. That's a benefit of using IPv6 is that there are shortcuts. You can collapse the zeros, but that's not the primary reason it was adopted. The IPv6 networks do not require any configuration or use of DHCP for large networks. Well, they don't require it because they have another way of automatically providing the addresses that devices need. So that's a correct statement, but that's not the primary reason why IPv6 was adopted. And Yeah, that's a benefit of its implementation, but that's not the primary reason why it was adopted. Okay. IPv6 access to resources. You are a programmer who must update your code to ensure a new website can be accessed using the IPv6 address. Choose the best answer statement for those listed below. So you may have cases where people are still operating with IPv4, but the web server itself is IPv6. The code needs to use square brackets following the HTTP : to enclose the IPv6 address. It's just that simple. These other answers are bogus. You use a dash, that's a separate case, but that doesn't. The dash symbol is used instead of colons for a separate case that has to do with another interest. So that is a related but not same or similar. You don't use dashes with the IPv4 address. Use a colon after the existing and then list the IP address. No, if you use a colon with the existing IPv4, what comes after a colon with a standard regular IPv4 address is the port number that it's on. So that's a bogus answer if you're using an IPv4 IP address. Cider Solution B. You were provided the following IP address and subnet mask for a network host on a public network: 27.143.22.147/24. For all sorts of reasons, the existing IP address cannot be changed. So you have a customer that has this address that has to remain. But the internet service provider needs to reprovision the existing network into segregated smaller networks for better use of, for better security and for better use of the public networks. Currently 250 hosts share the same subnet. The number of network hosts will be reduced so that 30 hosts will share the same network environment. So you're dealing with something that's going to provide a Cider multiple of 32. So basically what happens, there are plans to accommodate new growth for more hosts based upon the best practices. Using the appropriate Cider template, provide the network ID, gateway, and broadcast address for the new network environment where the host of the static IP address will be placed. Choose the best answer statement from those listed below. Well, if you're dealing with 30 hosts, you have one Cider template that comes close. It provides 29 hosts. Well, 32 hosts. 3 are designated for network ID, gateway, and broadcast. So technically the gateway is a host. So you're looking at 29 usable addresses. If you add the one for the gateway, that's 30 hosts. Which template are we talking about? Let's see. If it's a /30, that's a very small one. 4 hosts, that's a pinhole. 8 hosts, 16 hosts. Let's try the /27. Cider multiple is 32. There are 29 possible hosts. The gateway, if you add the gateway to that, you have 29 you can accommodate, and the gateway is the 30th host. Let's see. The solution reads that the original address is 147. If I look on this breakout, the first usable address that's going to work for 147 is this network number 5, which means the network ID is 128, the gateway is 129, and the broadcast is 159. So you're dealing with 128, 129, and the broadcast of 191. That would be an incorrect answer, but the closest one, because all the other network IDs and gateways presented are incorrect. So this would be the only answer that comes close. That's a typo, but the broadcast address should be 159 instead of 191. I guess I was in a hurry and put that one down. So we'll have to correct that for the retake. Anyway, that's the best choice. All the rest of these don't even come close. Those are different networks entirely. You have to use the one that starts with 128. That's network 5 and the gateway of 129. Alrighty. Socket definition. A network socket is used by programs to access a specific stream of data exchanged between two systems, a client and a server. And what's important to understand about sockets is that there are two. There's one that's formed on the client side and one that's formed on the server side. What data elements are used to compose an IP socket? Well, it's the IP address and the port separated by a colon. That's it. This is what uniquely identifies the session or connection. So you have the two sockets together, separated by a comma. So this would define a session or connection, not a socket. The other two answer choices, nobody chose this one incorrectly, but this one was, two people chose this incorrectly. The system IP address followed by the service port separated by two colons. No, that's what's used. Two colon characters are used to represent a number of continuous zeros in a string in an IPv6 address, so that's a bogus answer. That's not a socket for IPv4. So, moving right along. Next item. Headers during transport. During transport between networks, a router changes the headers on data passed to the next network. Choose the best answer statement from those listed below. So the layer 2 headers are changing, but the layer 3 headers do not. Basically, the headers of each frame are changed for layer 2 transport, though the IP headers remain the same. The IP headers are not changed along the way. They're preserved during transport, but it's the layer 2 headers of the frame, source and destination, that allow an IP packet to get from the destination all the way, from the source all the way to the destination. So it says the headers of each IP packet are changed for All right, nobody chose that answer. A router decides if a frame is part of the local network based on the ARP table for routing decisions. So an ARP table is used by a switch. It's not used by a router. A router has a routing table. It has routes that it references. It doesn't reference the ARP table. It's only looking at the IP address. So that's a bogus answer. The firewall, that's a bogus answer. Firewall is looking at application layer ports on layer 4, transport layer, and associating those with the given application if it's more than a simple stateless firewall. So if it's a stateful firewall, it's making some assessment decisions based on the port, but that has nothing to do with the IP packet headers. So this is the correct answer. This is also in your student notes, the slides what were provided by the author, and in our study guide. Cider subnet adjustment. This is another one we need to look at. So a company knows that the sale of one of their divisions to another company will greatly reduce the size of their company. Only half the number of network addresses will be needed. They use a Class B address range with a /16 subnet mask. A decision is made to use Cider to scale down efficiently. No future growth will need to be considered. How many places and in which direction should the company slide the values in the subnet mask? Well, if you're sliding to the left, you're increasing the size of the network. If you're sliding to the right, you're decreasing. And if you're cutting it in half, you're only making one slide to the left. So you're making a decision to use a /17 instead of a 16. You're sliding the subnet mask one place to the right by adding a single 1. So you have 17 ones. The other values are incorrect. If you're sliding to the left, you'd have a /15 network. You would double the number of addresses used. If you slide to the right, your subnet mask would be a /17 instead of a 15, so that's incorrect. The company should slide the one's values two places to the left. That would create a /14 network. That would quadruple the size of the network. So that's barfed. This is the only answer that's correct. Cider solution A, choose the best answer. So this is another Cider solution. Choose the best answer statement from those listed below. You are providing the following IP address and subnet mask. For a public, so we're using the same starting point for the scenario as we did in the other question, 27.143.22.147/24. For all sorts of reasons, the existing IP address cannot be changed. The existing network must be enhanced using a Cider solution to reduce the number of network clients to roughly 1/2 the original network. Using the appropriate Cider template, provide the ID, network ID, gateway, and broadcast. Well, if you're cutting it in half, you're going from a 24 to a 25, which means we're opening the 25 and we're looking at the 147 address. The 147 address falls not within the first usable range for network 1. 147 falls outside the first and last. It's the second network range, 130 to 254. So the network ID is 128, the gateway is 129, and the broadcast is 255. That's this answer. All the other answer choices are incorrect. And they're using different Cider templates. So that's the only correct possibility. A new service provider. So we have these two left, and then we'll slide up. A new service provider has set up local area networks in each building of a neighborhood for better security using managed layer 2 switches. However, no one can ping from any system in one building to the server in another building in an adjacent building. The provider has verified that each of the switches are properly connected to each other. Which actions will resolve this issue? So we have a bunch of different smaller networks. Okay? And no one can ping. So select the correct statement or statements from those listed below. A router must be configured with a proper gateway address for each LAN, and proper static routes must be configured. This is the same as your solution, 3.3. That's what you do to fix this. So you have managed switches, and maybe they're using IP helper, so that you have a single DHCP server, and each of those buildings have a different network scope or a different LAN, starting and ending addresses, right? But they're separate networks. They're segmented, which means they're isolated networks. The only way that you can get to a server in the next building is to have a route with a gateway. And that's how that answer is. Firewall rules are not the issue. I know that sounds like a common problem, but it's not. We're talking about a very simple ping. So if you've got separate networks set up, you have switches in each one that's configured properly, but what you don't have is a router between each network. Each system must have the same broadcast address? No. If each system has the same broadcast address to receive data from the external LAN, the broadcast address is only used in the local LAN, not external LANs. So that's an incorrect answer. Each system must have the same broadcast address and subnet mask to receive data from an external LAN. That's just a slightly different way of restating the same erroneous premise. So it's these two answers. A router and a route. In a nutshell, that's what you need. Last question for our multiple choice. Which network automation component provides a network client with the server address that provides dynamic IP address assignments? We're talking about DHCP, to connected hosts. The IP helper provides the DHCP server address. The DHCP server is the one that provides the automatic assignments. So we're talking about a way to automate the network. The IP helper service tells all the clients, here's where you go for your automatic address assignment. That's called DHCP. The network automation component that provides network clients with their own automatically assigned address, that's DHCP. The question reads, which network automation component provides a network client with a server address where to go to get their automatic assignment? That's IP helper. Okay? If the question read, which network automation component provides network clients with their own uniquely assigned, automatically assigned address and network criteria, that would be DHCP. But that's not how the question reads. A PIPA is when you don't have any dynamic assignments and you don't have anything, and you're not automating anything on the network. You've got nothing. So that's not a good answer choice. All right. So let's look at a couple of the multiple answer questions where the choices fell short and ordering. So here's a multiple answer that was a challenge. This true false, everyone got correct. This multiple choice, nearly everyone, but one person got it correct. So let's look at this multiple answer. Scenario B, DNS error. A system user notices a network connection has a pop-up notification that relates no internet is available. We're saying down here it says no internet available. That usually means that DNS is not active in the neighborhood. The user has entered a single known value DNS server address in the IP configuration for the system. However, despite this change, the notification persists and no web browsing or email is working. So they made a change down here, but they still can't clear that error. However, browsing to a website using its known IP, browsing to is possible, right? So that's the way this should read. The sentence says browsing, you can browse to a website using its known IP address. So your networking is correct, but you don't have a way to use the name for the network. Connecting to the network does not resolve the issue. Connecting to other networks does not resolve the other issue. What other actions or issues must be addressed for resolution? So if you connect to other networks, the point, all right, you're connected with Ethernet, you're connected with wireless, you still can't get it, but you have this known valid DNS server in there. What do you do to correct this? The user must clear the previous negative results from the cache using the IP. So when you had a problem before you made the change, there were negative results that accrued in the memory, the DNS cache, on the local system. So that has to be cleared with ipconfig /flush DNS. The actual DNS server may be temporarily down or restarting, causing this network error. That's another issue. So you could substitute You know, it could be down for a minute, and that's why, if you have one. That's why it's good to enter more than one. The user must enter a second valid server address as a backup. Oftentimes there's only one IP address. In home environments, it's usually the wireless router that's listed as the DNS server and the DHCP server, which means that if something happens to the one DNS server or that one connection, you're down. It says the user must reboot to clear the problem. That's not going to clear the cache. Believe it or not, that's not going to clear the issue if you don't have a second DNS server listed. The user should enable, yeah, if you reboot your system but the other DNS server is down, you're still out of luck. The user should enable NetBIOS over oh, heck no. You don't do that. That's bad. You never do that. You always disable NetBIOS over TCP/IP. Unless, for a special case, you're trying to join a domain and you just can't. You've done everything else. You enable it just for a minute after you've joined the domain, then you disable it. That's it's an old trick. We've never really discussed that in class, though. What we have discussed in class is that you never use NetBIOS over TCP/IP. Never, ever, never. That's not a good answer. That's the wrong answer. Multiple choice. That was correct. All right, so here we are. We're going to review these three next, and then we're done. The order of the TCP handshake. Host 1, a client, and host 2, a server, send and receive 2 SYN and 2 ACK data messages, 4 packets in total, to each other in a specific sequence to establish a TCP session between them using a three-way handshake. Order these in the proper sequence. So host 1 sends ACK to the host 2, right? So the client sends ACK to the server. That's step 1. No, I'm sorry. Host 1 sends a SYN packet to host, yeah, I'm down here. Sorry. Host 1, the client, sends a SYN packet to host 2, the server. That's the first step. That's the first step, yes. The second step, host 2 receives the SYN packet from host 1. The server receives the SYN packet from the client. That's the second thing. So the client sends to the server receives SYN from the client. That's 2. 3. The server, host 2, sends SYN and ACK back to the host, the original host, the client. That's the third step. The fourth step, the client receives back from the server the SYN and ACK from the server. That's step 4. The client sends an ACK back to the server saying, yep, I got your SYN packet. So the client wants to synchronize a connection. The server wants to synchronize a connection and acknowledges the original request to synchronize. And then the client says, okay, we're good. Host 1 sends ACK to host 2. The client sends an acknowledgement back to the server, and the server receives the ACK from the client. So the important thing to understand in this order is that there's a sender and a receiver, a sender and a receiver, a sender and a receiver. And so that's why there are 6 expressions here. In your next version, I will change host 1 and host 2 to client and server so it's a little clearer. Match the protocol with a purpose. So OSPF, open shortest path first, determines the shortest routes across the network. RIP, automates dynamic route creation. So there's static route creation when you build an IP route. That's called a static route. On the internet, those are automatically and dynamically created, kind of like DHCP, but for routes using RIP. That's routing internet protocol, right? So BGP, that has to do with redundant routers and networks. That's border gate protocol. If you have more than one connection to the internet, it helps your network infrastructure juggle the connection. When one's down and one's up, it automatically switches. That's what BGP does, redundant routers and networks. so that they seamlessly cut over when one fails. So BGP is for resilience, redundant, resilient, they kind of go together. NAT, it translates private IP addresses to public IP addresses. PAT, it translates a private IP addresses into a single public address using different ports. That's called port address translation. That's the answer. Okay, one final question for review. Let's see, which type of domain? Multiple choice, that was a... These are called top-level domains, .net, .com. The dot is the root. The net, com, biz, gov, edu, those are top-level domains. If you have uvi.edu, that's the parent domain. If you have students.uvi, that's the child domain to the parent. Root level is just dot. So that's what we're dealing with here. Let's see, multiple answer. So this is the last multiple answer. The rest, most students got these correct, and this is worth 3/4 of a point or a point. So let's look at this multiple answer. DNS error resolution. You have discovered the domain name is not established in a DNS server by the error you receive when attempting to browse to the website. You ensure the new domain is set up properly as a primary zone on a public DNS server. However, you still receive the same error message as before. What steps do you take to resolve this error? That has to do with clearing the local cache. So whenever you set up new records on a domain, in our second solution, we had to clear the cache on the server, then restart the server service, then clear the negative cache results on the client. Those three. And that's what we had to do to resolve that issue. These are really common problems whenever you implement DNS, and it's one reason why people just throw up their hands and they run screaming from the room. If you know to do this, clear the cache on the server, restart the service on the server, and then run ipconfig/DNS, flush DNS, you'll be the hero. If you create a secondary zone, that's not going to clear the issue. Or if you enter a static record for the hosts and the IP address, that's not going to help. You can't enter IP addresses into host name associations for everything you're doing on the internet. Your host's record would be ginormous. And that's all you'd be doing all day long. And then as soon as an IP address changed, the host's use of the host record is a very special case, and it's for a local server that's got a static IP address that you never want the local machines to get wrong, and that is not a good way to solve the problem. Oh, and LM hosts is not the file, it's hosts. So you can't say or LM hosts because, well, Linux and Mac systems don't use LM hosts. LM hosts is only used by Windows machines, but all systems use hosts. So that's the last common issue. Let's also take a look at this. Nope, that was 3/4 of a point. Only one person got one part of a choice wrong. Which do you want? All right, so let's look at these two real quick. You want to use the socket API to establish a client-server session with a persistent connection that streams data in both directions. Which transport layer IP protocol do you want to use? That's TCP/IP. The key to that answer is persistent connection that's streaming data in both directions. If you don't have a persistent connection and data is streaming from the server to the client, that's UDP. What is wrong with the socket implementation? So a programmer is using a graphic to build software for network clients using the sockets API. See image 1 below. for network clients using the sockets. See image 1 below. However, the client software is not working properly. Based upon the image provided, what conclusion can be drawn about the process shown? Well, part of the issue here is that we're talking about the client side, not the server side. So the steps that you're seeing here have to do with how a socket is created on a server, not on a client. In other words, the programmer is using the wrong graphic. They have to be using the shorter graphic on the client side to build the socket. It's not as many steps on the client, so they're doing too much. They're not creating a socket to bind and listen on the client. That's done on the server side. That's why it's not working. And it says here 3 steps are incomplete. That has to do with TCP/IP. That may not be the case if you're dealing with a UDP session. Steps are used only for UDP. Now, when you're creating a socket to connect, you're using the same process whether it's TCP or UDP. The 3-way handshake happens once the sockets are active, so that's separate. This concludes our item analysis for CSC 243, Module 3, first version of the assessment. Good luck on your retake. Please reconcile any errors you have, and if you have any other questions or clarifications you'd like on some of these items, feel free to contact me. I'm always available.